So, today's class, we're going to study the next important concept for IIT, JEE, MAINS, and as well as NEET. Even from this concept, JEE Advance also questions is to come because this is a very more realistic thing to our life. That is what like satellite launching, like recently what we launched, the moon's satellites, everything is based upon this is. So that's what it is like what velocity we have to launch the rocket, what is the fuel, how much distance it will travel, what is the escaping velocity, that everything out of Earth. So that's what is our concept. The next concept in gravitation, that is what escape velocity. So what is the derivation of this escape velocity? What is the concept behind it? And numericals, this all we are going to study in this. So in our today's class, we are going to see the most important concept for JEE mains and as well as NEET. So that is only escape velocity. So this is a more popular thing, mainly in the space technologies. The persons or people, those who are heard about the space or launching stations or satellites, constructions, this all. So this is the one where we'll always think about the gravity or gravitation. Of course, this entire chapter we have very close relation. So now, as we are enhancing on space technologies, so we are very particular about it. Now, so let me take, for example, I'm considering the Earth surface. Of course, Earth is not a completely spherical, but of course, I'm considering as assumption, Earth is a completely spherical in shape. So let me imagine, of course, if you are standing on the surface of the Earth, Earth is appears to be flat only. Am I right, everybody? Please respond. Earth is appears to be flat. Am I right, Pradosh? Yes, please. So now imagine somebody, let me take Mr. Pradosh is standing on the surface and he has been thrown some stone with some velocity. Let me take V1 velocity. So what is your observation? Anybody can tell? This stone will travel. It will take a certain path and travel, and finally it will reach us to the surface of the Earth. Am I right? Everybody clear? All of you?
Yes, sir.
So now, initially he has been thrown with some velocity. That is what V1. And after that, he has increased his velocity. So let me take it into V2. And it has been traveled some other more distance and it has been fall down. That is what it is. After certain time, again he has thrown with more increasing velocity. And after that, he has been taken V4. And that V4, you can see, it has been almost crossed the Earth surface. Means Earth surface is like almost up to here. So it has been fall away from the Earth. Means it is not returning to the Earth. It has been fall into the out of the Earth. So now, that is what generally basically we'll study in our 9th class. I think I have taught you people also. So that is what we used to call it as basically what we used to call everybody escape velocity. Means it has been went out of the Earth. Do you understand, everyone? It has been reached. If you imagine, like I want to show you the picture also. So now at that level, 9th class level, that is what the people will say is escape velocity. So imagine like rocket launching station. So Mr. Pradosh is launched the rocket with like stone V1 velocity. So after traveling certain distance, it has been fall into the where? Everybody. It has been fall into the again what? On the surface. Am I right? So the rest can understand what I'm saying? Yes or no? Everybody please involve in the class.
Yes,
I
sir.
think I'm audible very loudly. So these all are very interesting concepts, no boring concepts and all. So you can all active participation, more interest you can. Now, again he launched with some other velocity V2. So it has been taken a little bit more longer curve and has been finally fall into after certain distance, it is reached to the surface of the Earth again. Now he has been thrown with some other velocity V3. So now you can see it is never reaches to the Earth. It is been keep on revolving and it is came back. So now basically this is what we used to study. This is a velocity of a satellite or whatever it is, escaping velocity, which is makes the satellite to revolve around the Earth continuously, not to reach the surface back. This is what we used to study. What is that velocity we used to say? All of you?
Escape velocity.
Escape velocity. This is what, let me take escape velocity is V. So this is how the 9th class we all will study. But is it the escape velocity? No. So remember, this is not exactly the escape velocity. So by this time, class 9th, We'll never study any formulas, derivations, anything. So that's what simply we can say the velocity which is required to make the satellites to move or the anything rocket to go is not to reach the earth back. So why it is reaching the earth back? Because of there is a force. What is that force which is always pulling towards the surface of the earth? Anybody? What is the force which is always pulling towards the surface of the earth? Anyone?
Gravitation.
Gravitational force. Do you understand, everybody? So like that, he has been keep on, imagine a person, he's been keep on increasing the velocity, increasing the velocity, increasing the velocity. So case number one, everybody. So if you notice it, of course, he increases the velocity, V1, V2, V3 and all. So let me take it now. If he been made V3 velocity, so this is the case number one, velocity keep on increases, increases, increases. For example, case number one, everybody take it, everybody. So if it is thrown with a particular velocity, so what will happen, everybody? Let me imagine V is keep on increases, keep on increases, keep on increases. So we all know this Kepler's laws of motion. Do you remember Kepler's laws of motion from 9th class? Anybody? Yes, Pradosh? Kepler's laws of motion, Kepler's planetary laws of motion, or Kepler's laws of motion. So what is Kepler's first law? All of you observe very carefully. Once again, I will teach you. So Kepler's first law alone, you remember. Kepler's first law of motion. That's why I said class 9th, you please learn. So Kepler's totally proposed 3 laws. Kepler's first law, we used to call it as a, what we used to call? Law of orbits. So what we studied in 11th itself, we don't know what we remember 9th. This is what you have to remember. Law of orbits. What law of orbits? The planets are always revolving around the sun in elliptical orbit, and this elliptical path is having 2 axes. One is major axis and another one is what, everybody? This is major axis and another one is what, Rudreswa? Minor axis. So minor axis. What is Kepler's first law? I'm saying you people, please observe. So Kepler's first law will say is, so every planet is revolving around the sun in a particular orbit. That orbit is not a circular track. What is the track, everybody? What is the track, everyone? It is the elliptical track. Please remember, elliptical track. Now, it is having a 2 focus. One is F1, another one is F2. Now, sun is present. Sun is present at any one of the foci, any one of the foci. That is what we used to call it as a Kepler's first law. What is Kepler's first law? For those, are you trying to get it? What I'm saying? Yes, everybody? Please respond. Yes. So Kepler's first law will says that sun is present at any one of the foci and planets are revolving around the sun in a which path? Everybody?
Elliptical path.
Elliptical path. That is what we used to call it as a Kepler's laws of first law of planetary motion. Anybody having any doubt, you can ask me, or else just have a glance. 3 minutes video we have. Let me finish this. You just watch it, and then of course I have taught you. Our 9th class, everybody used to study. If you are there, are my students or not, but still you might be forgot it.
How to
See that you will definitely will have a recall. That's what.
out the free version.
Okay.
Kepler's laws of planetary motion.
Observe very carefully. Extremely important concept in entire gravitation. This is the first laws which will describe about the motion of the planet, and it has been proved. And we studied universal law of gravitation. Do you remember what is universal law of gravitation? Tell me, everybody. What is universal law of gravitation? Force of attraction between any 2 bodies. Speak, guys. Force of attraction between any 2 bodies, which is equals to what? All of you. Capital G into capital M into small m divided by what? Distance between the 2 bodies. R square means what? Distance between the 2 bodies from their centers. So that is what? So F is directly proportional to product of their masses. F is inversely proportional to square of the distance between the 2 bodies from there. From there what? From their centers. Do you understand, Mr. Rudreswar? Remember? Now, this is the one we used to call something. Anybody can tell what we used to call that one? This is a name for that. That is what we used to call it as a inverse square law. Yeah, inverse square law. This inverse square law, Mr. Newton has been derived from whom? It has been taken from Kepler's laws. Kepler's third law. Exactly, if I want to say, it has been taken from Kepler's laws. Simply remember. From the Kepler's laws, that is also after 40 years of Kepler's death, Mr. Newton has been taken and it has been formed universal law of gravitation. So already I have taught you universal law of gravitation. Now anyhow, it's time to study Kepler's laws also. That's what I'm making. Already you studied in 9th class, but once again, just have a glance and you finish it. So 3 laws we have. Kepler's first law, law of orbits. Kepler's second law, law of areas. Kepler's third law, law of time periods. Once again, I'm repeating. Kepler's first law, law of orbits. Kepler's second law, law of areas. Kepler's third law, law of time periods. Do you understand what I'm saying, everybody? Clear? All of you?
Yes, sir.
Yes. So have a glance, stare at the video. It's very beautiful video and makes you definitely recall what you studied in the 9th class.
Kepler's law सोलर सिस्टम में प्लैनेट्स के मोशन को डिस्क्राइब करता है। केपलर के 3 लॉ है जो कि
Wait, it is actually in yes, it is in Hindi. We'll make it into
इस वीडियो में हम समझेंगे
again Hindi. I want in English.
केपलर्स
Just a minute. Yes.
Kepler's law of planetary motion. Kepler's first law. The orbits of the planets are ellipses with the sun at one focus of the ellipse. There is no object at the other focus of the planet's orbit. The semi-major axis A of an orbit.
Do you understand, everybody? Elliptical orbit having how many focus? 2 focus, and sun is present at any one of the foci. Sun is present at what? Any one of the foci. Do you understand, Amma? Everyone? So that is what you have to remember. Sun is present at any one of the foci. In English, I forgot it. What is the video it is? So let me make it. So there is a video. It's a very beautiful video. I've shown to yours. Okay, let me watch.
In this module, you will learn about Kepler's second and third laws of planetary motion.
Okay, these are all useless. So we'll go with the first only. Hindi only, nothing will happen. Hindi, I'll explain. Yes, I'm there to explain you. No need to worry. So this is, I think this is only. Am I right? What is the first video? This only, brothers? Yeah.
केपलर्स लॉज ऑफ प्लैनेटरी मोशन। केपलर्स लॉ सोलर सिस्टम में प्लैनेट्स के मोशन को डिस्क्राइब करता है। केपलर के 3 लॉ है जो कि इन तीनों लॉ को खोजने वाले साइंटिस्ट के नाम पे ही रखे गए हैं। केपलर एक जर्मन एस्ट्रोनॉमर थे जिनका पूरा नाम जोहान्स केपलर था। केपलर के तीनों लॉ को समझने से पहले हम एलिप्स से रिलेटेड कुछ बेसिक टर्म समझेंगे। क्या आपको पता है फोकाई टर्म हम एलिप्स के लिए और फोकस।
So listen, everybody. So the orbits, the planets are not having circular orbit. What is the orbit actually? It is elliptical orbit, and each elliptical orbit is having what? 2 focus. One is, first remember, 2 axes. One is minor axis, semi-minor axis, and another one is what? Semi-major axis. And semi-major is axis having 2 focus. That is F1, and another one is what? F2. So sun is present at either at F1 or F2. We don't know that. Sun is present at any one of the foci, and planets are revolving around the sun. That is what Kepler's first law. Are you clear, everybody? That is only call it as law of
Orbit.
okay.
Orbit.
Now remember, whenever, suppose if I imagine, everybody, whenever the sun is, if I imagine sun is at F1. Now remember, whenever the planet will far away from the sun, the speed of the sun is less. Sorry, planet is less. Whenever the planet will come closer to the sun, Because of force of attraction increases. Because distance increases, force of attraction decreases. So distance decreases, force of attraction increases. So whenever the planet will come closer to the sun, the velocity of the planet is increases. Whenever the planets are far away from the sun, velocity of the planets will what? Everybody? Velocity of the planet will be decreases. Clear? That is also you have to remember. Okay, make it quick. We'll finish.
टर्म सर्कल के लिए यूज करते हैं। इलिप्स में 2 फोकाई होते हैं और सर्कल में एक फोकस। इलिप्स में दोनों फोकाई मेजर एक्सिस पे लोकेटेड होते हैं। तो चलिए अब समझते हैं केपलर्स फर्स्ट लॉ। All planets move about the sun in elliptical orbits, having the sun as one of the foci. कहने का मतलब कि सभी प्लेनेट सन के चारों ओर एक एलिप्टिकल ऑर्बिट में मूव करते हैं और सन एलिप्टिकल ऑर्बिट के किसी एक फोकाई पे लोकेट होगा।
Indian English both
प्लस
are
सेकंड लॉ। चलिए
Second law?
हम मानते हैं
Yes,
कि
please.
एक स्ट्रेट लाइन जो कि सन और प्लेनेट को
Imagine
ज्वाइन
now.
करता है, इस
Very
लाइन को
well.
हम रेडियस वेक्टर बोलेंगे। मानते हैं कि प्लेनेट किसी टाइम इंटरवल t में पोजीशन P1 से पोजीशन P2 तक मूव करता है। अब
Yeah, just imagine. Just see, this is the imaginary line. It is not acting anywhere. Now, let me imagine at the beginning of the April month. I'm sorry, now it is what month? October month. So October 1st, just I'm taking because it is the time period is around 365 days if you consider for Earth. If you consider for Earth, what is the time period to revolve around the sun? Everybody? 365 days. So it is not the small time period. So I'm considering little large time period. If I take large time period, please try to understand. If I take, for example, this is the 1st October, and if I've taken this is 30th October. Now, by this time, definitely it has been traveled certain distance. Am I right? Can you understand, brothers, what I'm saying? Now, if I join that initial point and final point in October month, and I make a imaginary lines from the sun, and if I calculate this area, let me take this area is A1. What is this area? Everybody? A1.
A1.
Understanding? Now, some other month, let me take, now the planet is at here. Just I'm saying you. Let me take this point is P3, and it has been again, when it is closer to the sun, I said, it has been travel faster or slower? It will travel faster or slower? It will travel faster. So let me take it is P4. Now, if I imagine these two imaginary lines from the sun, imagine these two imaginary lines from the sun, and if I calculate this all the area, which is equals to A2. So here maybe it may travel faster, here it may be travel what? Everybody. It may travel, please respond. It may travel faster or here it may be travel slower. Doesn't matter. Here I have taken again same. Let me take, this is a January month. Now this is a Jan 1st, 2024. And this is Jan 30th, 2024. Because now it is a 2023. So January month, the planet is here. So now it is covered in this month, A2 area, imaginary lines. So what is second law of planetary motion? That is what we used to call it as law of areas. What is to call? Rudreswa? Law of areas we used to say. So what does it mean? Means in a equal time period. Remember, time period you should not take small. Why? Because it is very, very large distance. So you should take a measurable time period. So little large period. So that's why I'm taking at least 1 week or 1 month like the time period. So whatever the area it will sweep in October month, same area it will sweep in the January month. That is only call it as a law of areas. Equal areas will be swept out in equal interval of time. What is that? Equal areas will be swept out in equal interval of time. Do you understand, everyone? Girls and boys, anybody having any doubt? Let me know. I hope you all understand. Everybody?
Yes, sir.
Please. Yes. Or else you take another month. For example, at some other month it is at here. Let me take this point is A1, or let me take B1. After a certain month, 1 month, same time period, that is what? Equal time period. Let me take this point is B2. Now from the sun, if I join this, this area, let me take A3. So what will happen? A1 is equals to A2 is equals to A3. So irrespective of position of the planet from the sun, in a given time period, always planet will sweeps equal area in equal interval of time. Do you understand, Mr. Kadir, Rudreshwa, Pradeep? That is only call it as a law of areas. Now I will show you. Observe very carefully and play it. Listen.
क्योंकि प्लेनेट की पोजीशन के साथ रेडियस वेक्टर भी चेंज हो गया है और अपने साथ सर्टेन एरिया कवर करता है, जिसे हम A1 मान लेते हैं। अब इसी प्लेनेट को हम दूसरे पोजीशन पे कंसिडर करते हैं। अब ये प्लेनेट P3 से P4 मूव करता है और इस बार भी टाइम इंटरवल T ही माना गया है और एरिया जो कि रेडियस वेक्टर कवर करता है उसे हम A2 मानेंगे। केपलर्स सेकेंड लॉ के अकॉर्डिंग एरिया A1 और एरिया A2 इक्वल होंगे। Kepler's second law of planetary motion. A radius vector joining any planet to the sun sweeps out equal areas in equal lengths of time. Kepler's third law. चलिए मानते हैं कि एक प्लेनेट P सन के
Okay.
अराउंड एक
Hey, second law understand,
एलिप्टिकल
Ara?
ऑर्बिट
Pradosh?
में रिवॉल्व कर रहा
I
है।
want to know, Sai Karthik, everybody. I hope you all understand. You are all
Yes, sir.
11th class now. More than me, I don't think so. It is. Do you understand, everybody? Everyone, Manya and Samya, Sai Karthik. Clear? Yes. Please, if you have doubt, please ask me. Don't hesitate to ask. You're all 11th class. Still any problem is there, I will explain. It's not a problem at all. Now, third planet, third law. I will explain before because this video is not just for me. It's just to make you visualization. Nobody will spend this much time in the 11th class for Kepler's laws. But without that, there is no gravitation concept. That's the reason we are spending. So you should understand the importance. Now, Kepler's third law. There is a derivations for everything. There is a proofs. The time being, you will study everything. That's what it is. So you should be able to concentrate. Now, what is third law means? So let me take, as we know that the sun is, the orbits are its circular shape or they are elliptical shape. Everybody? The orbits are, planets' orbits are elliptical shape or circular shape. Everyone? Yes? Elliptical shape. See, remember, if it is a circular shape, what is circular shape? Everywhere radius remains constant. Am I right or wrong? All of you? But if it is an elliptical shape means, does it R remains constant? That is what is my question. Everybody? Yes, please. Sometimes planet is closer, sometimes planet is very far, sometimes closer, sometimes very far. That's why you can see our day and night time duration will be varies. So that's why I'll take always from the sun instead of taking R because radius is not constant. I will take average radius. What is that I'll take? Everybody? Average radius. Do you understand, everyone? That is also capital R, or you can take it as a small r, your choice. Now I am having, imagine, if this is the sun it is, I am taking this is the P1 planet. What is this planet? Everybody, P1, different orbit. I am taking this is the planet, this is the P2 planet. Now you tell me, does it, every planet will take the same time to revolve around the sun or different timing it will take? That is what is my question to you. Because they are present at different distance. So different distance, averagely, they are present at different distance from the sun, orbital velocity. So does it orbital velocity remain same or varies for everything? Everybody, what is your opinion? You can tell. Distance increases, so force of attraction. For example, the sun's gravity on Mars and sun's gravity on Pluto, is it same? Sun's gravity on Earth, is it same? I'm asking you. The gravity of the sun on the Earth, gravity of the sun on the Jupiter, is it same? That is what I'm asking.
No, sir. No, sir.
So definitely the time period it will be varies. Am I right or wrong? You might be heard the news also. In a Jupiter, I think in a Neptune or Jupiter, there 50 years is equal. Sorry, in Earth 50 days is equals to there equals to 1 day. Here 1 year is equals to there equals to 1 month. Like that we can use to heard it. Am I right or wrong? All of you, do you understand, everybody? So that is
Yes,
very
sir.
what different planets will be having different time period around the sun. Am I right, Pradosh? And different average radius. Their planets are not in the same, different orbits they are. So different average radius. Now, for planet 1, let me take the time period. Average time period is T1 and average radius is R1. For planet 2, time period is T2, radius is R2. Now, what is Kepler's third law? Kepler's third law is also called it as law of time period. What is to call it, everybody? Law of time period. Okay. So what it exactly says, all of you observe. Time period square of time period is directly proportional to cube root of average radius. Square of time period of a planet is directly proportional to cube root of radius. We all know mathematics, if you remove the proportionality, we have to bring it what? Everybody? Constant into r cube. Or you can say cube root of r, cube of r is directly, average radius is directly proportional to square of time period. Both are correct. So now, constant into r cube. So I will write for planet 1, that's what? T square divided by r cube is equals to constant. That is only call it as a Kepler's third law. I think I am doing a mistake. It is not T square. R square is directly proportional. Okay, we'll verify it. If any error, we'll modify it. So now for planet 1, I'll write T1 square divided by r cube only. T1 square divided by equals to constant will come. Next to planet 2, tell me what will come. Planet 2, T2 square divided by R2 cube, which is equals to what? Constant. This both constant. If you do any planets, always you will get the square of time period divided by cube root of average radius. You will get the same constant. That is why it is called it as a law of what? Law of time period. Or you can do reverse. R1 cube divided by T1 square. R2 cube divided by T2 square, each equals to, will get, like any planet you will do, you will get remains constant. This is only call it as law of time period, Kepler's third law of planetary motion. What is to call? Kepler's third law of planetary motion.
इस इलिप्टिकल ऑर्बिट के दो एक्सिस है, मेजर एक्सिस और माइनर एक्सिस। मेजर एक्सिस के हाफ डिस्टेंस को हम सेमी मेजर एक्सिस बोलते हैं। प्लेनेट पी सन का एक रेवोल्यूशन टी टाइम में कंप्लीट करता है, जिसे हम टाइम पीरियड कहते हैं। चलिए अब देखते हैं केपलर का थर्ड लॉ क्या कहता है। Kepler's third law, the square of a planet's orbital period is proportional to the cube of the length of the semi-major axis of its orbit. कहने का मतलब कि टाइम पीरियड का स्क्वायर सेमी मेजर एक्सिस के क्यूब के प्रोपोर्शनल होगा।
Is it true what they are saying? Time period, is it hours and that is true? Yeah, correct only. Yeah, right. That's fine. Clear everybody? But here r means not radius because it is not a spherical in shape. What is the shape actually? It is the elliptical shape. So here r means what, everybody? We are taking average radius. Do you understand, everyone? All of you clear? Please respond.
Yes, sir.
This is what we used to call it as third law. So for every planet, if you do square of time period divided by radius square of cube of radius, that's what average radius, always you remains will get it what, everybody? Will get the same constant. Even for 9th class present, your juniors I have taught and we have been proved it also. Almost 6 planets we have been done. Do you understand, everybody? Do you understand, all of you, what I'm saying? So it has been proved.
Yes, sir.
So it is correct. So that is the Kepler's third law. Now, if you observe, everybody, all of you, so now if the Mr. Prados is keep on increasing the velocity. So at certain velocity, this orbit, I forgot it. Is it, can you able to see my screen? Nothing, am I right? Yes. So now you can see, this is not actually exactly spherical. So if Mr. Prados is keep on increasing the velocity is keep on increases, point number 1. So at a certain velocity, the body will take it elliptical path. That is what you have to remember. Certain, this is not true, remember that. So as we know, semi-major axis and semi-minor axis. So at certain velocity, body will take what path, everybody? First point you have to remember. Yes, Mr. Rudreswar? It will take what, everyone? Elliptical path. Clear? Next. If the velocities keep on increases, second point, you keep on increases. Where? velocity is approximately equals to 8 kilometer per second. For Earth alone, I'm speaking. Are you understand what I'm saying, Rudreswar? Are you clear? So at this time, please keep it in mind, like imagine velocity v is equals to root over gr. So at this time, the body will take circular motion around the planet. Circular motion around the planet. When? Where the velocity is almost root over gr. That's what approximately like Earth, 8 kilometer per second. So where the velocity become, understanding, root equals to root over gr, then it will take what motion, everybody? It will take surrounding by the Earth. What motion, everyone? Circular motion. Purimara Pradosh. So by the time, if you consider this is the planet, it will go in a circular motion around the planet. Do you understand, Mr. Rudreswar? Every point I'm speaking about the circular escaping velocity. So this, does it call it as the escaping velocity? No. Now, if the velocity, it is not, if it is making a circular velocity, it is not a escape velocity. So please note it. What is escape velocity? We'll understand. We'll find it. So escape velocity. Next. If this velocity, third point, please note it. Third point. If this velocity keep on increases, that is what? Velocity rises, which is greater than root over gr, which is greater than how much? Which is greater than root over gr. Do you understand? Again increases. So now, in this case also, the body will again takes another elliptical path. Elliptical path. For Earth alone, I'm saying you, elliptical path. Now, if this velocity, third point, fourth point, if this velocity again increases, where velocity is approximately equals to 12.2 kilometer per second, 12.2 kilometer per second. So by this time, imagine Mr. Pradosh has been thrown and it has been went, like, understanding, where velocity is approximately 12.2 kilometer per second. That is what? In this situation, the body has been taken almost, imagine, the thrown body will be taken into the parabolic shape. This is what we used to call it as parabolic path. It will take the parabolic path. This is what we used to call it as. It will escape. It will escape from the Earth gravity completely. So that is what we used to call it as, where velocity, escape velocity is equals to 2gh. Of course, we'll calculate it again. So where velocity will become what? Escape velocity by this time, everybody? Escape velocity will become how much amount? Root over 2gh. By this time, what is the path it will take, Pradosh? It will take what path? Parabola path. Okay, these all are conditions for escaping velocity. Now, the path 4 is actually escaping velocity. So it is actually parabolic path. Now, fifth point, if this velocity is again keep on increases. See this is an open curve. Till now, every curve is a closed curve. Fourth one is only open curve. Now, velocity keep on increases, where it is greater than root over 2gh. Greater than root over 2gh. Imagine Mr. Pradosh is standing on the Earth. Then it will go like almost, remember, path number 5 is almost like, if you imagine this is the Earth. It will take whatever the axis, wherever it is there, anywhere, it will take it into almost hyperbola path. What is the path it has been taken? Everybody? Hyperbola. Understanding? Hyperbolic path. So this is what path 5 and path 4. This is what we used to call it as a escape velocities. So now, all of you observe very carefully. This is what the 5 points which will speak about the escape velocity. So 1, 2, 3 paths. 1, 2, 3 path. They are making inside the Earth. That's what inside the Earth gravity is only. It will be existed. They are not been escaped anywhere. Like in chemistry concept. Let me go to the PDF and that Word document I will say you. So like imagine electrons are always revolving around the nucleus. Why, Mr. Pradosh, Rudreswar? This is the nucleus, and electrons are revolving always around the nucleus. Why? Because there is a energy which is binding them and make them to revolve in a continuous path. Am I right, everybody? Yes, please. All of you, please respond.
sir.
So that is what. So where velocity become, keep it in mind, all of you, where velocity is greater than root over 2gh or velocity is equals to root over 2gh, this is what we used to call it as a escape velocity. Hey, can you hear me, everybody?